Okay, what is OSI layer? It is Open System Interconnect. Guys, we have a different type of protocol suites are there. TCP/IP protocol suite, IPX, SPX. Different type of protocol suites are there earlier. So then, to make a communication between the devices, different type of communications, mail communications, messaging communication, data sharing, web communication kind of stuff. Okay, so by getting observations from different type of protocol suites, and this is a standardized model is created by IEEE, and it is standardized by ISO, International Organization for Standardization. ISO is given a standardization for OSI. It is a standard model, but no one is using a OSI model because it is a reference model. It is used to understand or create and troubleshoot a network. You want to create a network, you want to understand a network, you want to troubleshoot a network. Okay, this OSI layer is helpful. This OSI model contains 7 layers. This OSI model contains 7 layers. That's why we call this one as also 7-layer model. Okay, 7-layer model. Of course, there is a lot of names are there. In different naming structures, other means like what can different organizations also names are there. So that's we will see later. First of all, so OSI model is a 7-layer model. It is a reference model. Reference means just for reference only. We don't use this in the real time. But in a real time, so we have with the help of OSI model, we can troubleshoot the network. We can understand how the network is working and all. Okay. So totally it is having 7 layers, right? So if you want to read it from starting to like that, so it is showing I received a message, but where I received? Okay. Not required. Okay. Guys, some people read or tell like this, voice a model from application to physical layer, application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Some people tell no, that is wrong way because the layer 1 is a physical layer. So you have to read it from physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Which way is correct? Both are correct, guys. Both are correct. So how both are correct? When you are sending a message, so this is a source and this is a destination. When you are sending a packet, so first one is application layer, last one is physical layer. So from application layer to physical layer and packet will forward. Okay, the physical connectivity is there now. So physical layer of destination will receive the message and it will go up to application layer of a destination message. So while you are sending application to physical, while you are receiving physical to application layer. So either it is 7 to 1 or 1 to 7, both are correct. But as per the number sequence, it is the first layer is physical layer and last layer is application layer. Okay, and these 3 layers, application layer, presentation layer, session layer. So these 3 layers are top layers or upper layers and mainly the software layers. And last 3 layers means network layer, data link layer, and physical layer are at bottom layers and hardware layers. So while we are a discussion about devices, hubs, switches, routers, And we are giving example for layer 1 is hub, layer 2 is switch, layer 3 is router. Of course, that time it is reverse. Hub is a layer 1 device, which is a layer 2 device, router is a layer 3 device. So hardware wise, the compatible with that layer protocols. Okay. So these are the 7 layers. I'm giving this middle 7 layers. So how to remember? Okay, guys, look at here. So as a part of application layer, plus one more point I want to tell here only, that's why it is, that is a protocols and port numbers. Okay. Either before or after, so we'll see, must we have a space here, that based on that. Guys, protocols are, I will change a little bit. The first layer explanation I'm giving, guys, that is a application layer. So then I will tell about these protocols in that one only. Application layer is the first layer in the top wise layer. Application layer, presentation layer, session layer. This is the application layer. It is belongs to application part of a communication. Like I'm using a web browser to communicate my remote machine, right? I want to open a YouTube. So where I'm opening the YouTube website in the web browser only. So what is my application? Web browser is my application. YouTube is my destination. Okay. And similarly, when I want to receive a mails, I use a Outlook mail client application. Okay. This is the Putty. I want to connect my remote machines with SSH or Telnet. I use this application. SSH or Telnet. I use this application to connect remote machines. Okay. And you know the FileZilla. This is FileZilla. It's an application used to upload or download a data through FTP protocol. Okay, remote server, I want to upload or download a data, I can use this application using FTP protocol. Like this, guys, different protocols, different type of communications, we use different type of applications. Okay, different type of applications. Next, from client side I said, but what about the server side applications? You want to access a website means there is a web server. How a certain machine or a server become a web server? By installing the related protocols, sorry, and the related packages, applications, uh, built-in roles like that. Like there is a DHCP server and our machine is DHCP client. Right, DHCP server give IP address. Our client machine got an IP address. So how it is can able to give an IP address? How it is become DHCP server? By installing some package or by built-in roles or features. If you install a tomcat, it is become application server. If you install a Microsoft Internet Information Service, it is become a web server. Install a Microsoft Exchange application, then it is a mail server. So there is a server by server side application, client side application is there. So server and client will communicate each other and understand what type of service it is by using protocols. Using protocols. Server and client will communicate each other by using their set of protocols. Okay. What is the protocol? So protocol used to understand what is the request from client and server. So it is exactly say it define what type of communication. It defines what type of communication. It is a web related communication, or it can be a file upload or download communication, or maybe it is a mail communication, or it is a synchronization, time synchronization, or it can be a authentication related or remote access related. Okay. So what type of communication it is, it will be understand. Okay. Understand by protocols only from both client side and server side. Server to client will communicate using protocols only. Again, guys, protocols will define what type of communication it is. Okay. What type of request from client and what type of what is response from servers we can able to understand. So this is what I am trying to say, highlighting. So like this. Guys, I am giving a certain protocols list. Give you certain protocol list. So this protocol are generally using protocols. That's right. Yeah. Just I want to put a one picture. So is it possible? Now same problem. Why I am getting this problem? I don't know. Still, there's some problem in my PC. Okay. So here is a diagram. So you can see this is a PCA and this is a remote server. Actually, server is a web server. I send a request. It's a HTTP request, and the server respond to the client. So I send a SMTP request. This is the web server, right? Web server respond to the HTTP request, not a SMTP request, because it's a mail request. It's not a mail server, so it won't give you any response. Okay. So compulsory. What is the client? What is server? That is which is important. So they will understand by protocols and port numbers. Guys, these are different protocols. Some protocols I added here. Okay. Look at here. This is HTTP. HTTP protocol. Use it for a web communication. HTTPS. Both are for a web communication. HTTP, HTTPS. Both are used to for a web communication. HTTP, the data is transmitted from server to client or a client to server without any encryption. Server to client and client to server without any encryption. Okay, I'm sending a data or I will receive a data from server to client, client to server kind of stuff. No encryption means data is exposed to outside. HTTPS, it is a secure. It is a secure. It is also called over SSL. Data is encrypted. Whatever your HTTP data, web data is encrypted. Data is encrypted means if anybody got your data, what is the data you are sending and receiving, the data cannot be understandable. So it is completely encrypted data. That is the difference. This is also one important question, guys. Difference between it is showing HTTPS reference. Fine, remember that. So HTTP not encrypted. HTTPS is encrypted. FTP, file transfer protocol, use it to upload or download a file. The port numbers are showing, guys. The port numbers are representation of protocols. There is a 65,536 port numbers are there. Out of 1023 port numbers are reserved port numbers. Some port numbers are reserved for a certain protocol. Some port numbers not reserved. Means you must use these port numbers for these particular protocols while you are communicating in the network. So instead of telling what protocol it is, we tell in a port number manner. Okay, that is important. Compulsory. Try to remember, maybe now or later, whatever it is. Okay. FTP 2021. SSH is a protocol used to connect remote server. I want to access a remote server. Access means I'll connect it to remote server and will do certain configuration in the server. I'll work with this server. I can do it. So this is my SSH server. SSH server means, for example, it is my Linux server. This is my Linux server. I want to do certain configuration in my Linux server. So I can able to connect through network to this Linux server using SSH protocol. SSH is a encrypted type, secure shell. SSH means secure shell. Shell, SHEL, shell. Secure shell. Port number is 22. So whatever the data is transmitting from your PC to the remote Linux PC is data is encrypted. Another one is Telnet, same as SSH. So here I have a remote server. Okay, remote machine is there, and I'm connecting this remote machine using Telnet protocol. This Telnet also remote access, and both are CLI based communication. CLI, command line based communication. So command line wise we can able to access. Okay, so this is a Telnet server, so I'm connecting to Telnet. For example, it is can be a Windows or Linux or remote devices, anything. I'm connecting through Telnet. Okay, it is also remote access but no encryption. SSH encryption, Telnet no encryption. Both are for remote access purpose only and CLI based communication. RDP also remote access purpose only but not CLI based. It will access entire desktop environment. If you see, this is my desktop environment, right? This entire desktop we can able to access through network. Like this is my client. I'm connecting through RDP, remote desktop protocol, to this desktop. So then this entire desktop environment I can see from here. Okay, it is a GUI type, means graphical user interface type of access. So for example, here I have a Windows server. I want to access this Windows server from my PC using RDP. I can able to access. SMTP, Simple Mail Transmission Protocol, POP3, Post Office Protocol, IMAP, Internet Mail Access Protocol, something is there. Instant Mail, IMAP. It is, my Google is not at all working, nothing is working actually. Guys, SMTP, POP3, IMAP version 4. These three protocols used for mail communication. You want to send a mail, SMTP protocol. To retrieve a mail, you send a SM POP3 protocol or IMAP protocol. Okay, SMTP, POP3 and IMAP version 4. Next one is TFTP protocol, Trivial File Transfer Protocol. Trivial File Transfer Protocol. Okay, so like a FTP will upload and download a files, but TFTP is a trivial file transfer protocol. So remote device configuration purpose, like either you take a backup of remote PC configuration, or maybe you want to upload or restore a backup configurations like that. So only that kind of stuff use TFTP, trivial file transfer protocol. DHCP, Dynamic Host Configuration Protocol. It will provide this DHCP servers will give IP address. It is assign an IP address to clients automatically. DNS gives IP address of domain. Sorry, so you open a website like a google.com, facebook.com, youtube.com kind of stuff. Then I'm trying to open w3schools.com. So I don't know what is an IP address of this w3schools.com. Then my DNS server will give you the www.w3schools.com IP address. Okay. You open a youtube.com. So then you don't know what is the IP address of youtube.com. The request go to DNS server. DNS server will give you youtube.com IP address. Okay. So DNS server. NTP, Network Time Protocol. So if you go through this, it is, I am getting this time from my NTP, Network Time Protocol. You can go to check that one from here. So not here, sorry. So not here. Adjust date and time. So you can see this time.windows.com is my time server. From the time server, I'm getting this date and time. The date and time is configured to my PC from time.windows.com based on my time zone, based on the time zone. Kerberos and LDAP both are authentication protocol. Kerberos and LDAP both are authentication protocol. Kerberos mainly used in a Microsoft Active Directory environment. LDAP is more like a Linux and other systems use LDAP. It is a more like a open LDAP type, means anyone can use LDAP for authentication protocol. Okay. SNMP, Simple Network Management Protocol. SNMP, Simple Network Management Protocol. It is the protocol used in the monitoring, in a monitoring place. Okay. So these are the different protocols. Not only these protocol guys, there are so many protocols and with their port numbers are there. This is I am giving some of the protocols. Okay, most frequently used protocols. And protocol and their port numbers are also important, and difference between HTTP, HTTPS is also a most common question. What is difference? HTTP, no encryption, HTTPS, encryption. HTTPS is secure like that. So when we use, so when a server put a HTTPS type websites is a secure, data transmission is secure. So then mainly banking, social media, email communications use HTTPS to secure your data while transmitting and receiving. Okay. And nowadays most of the websites are HTTPS. Okay. So we are completed only application layer, and next one also we'll see. This is a picture drawing is not working, so still not working. Guys, understand what is protocols and port numbers? Okay, application layer. No one is speaking. Are you able to hear?
Yes, sir.
Then why now people are responding?
Yes, sir.
Already I am having this networking problem. Guys, next two layers are a presentation layer and session layer. Okay, presentation layer and session layer. Yeah, tell me. Yes, presentation layer is do three things. So each layer, guys, first layer is dealing with an application. What is an application? From where you are applying. Okay. Means what application you are using to do communicating, right? Either you are sending or receiving what kind of application and what protocol, what is their port number is important. So presentation layer data is, so whatever the data in at application, it encode the data and decode the data, and it compress the data and decompress the data, it encrypt the data and de-encrypt the data. While you are sending, you will encode the data and send. While you are receiving, you decode the data and you get the data. So while you are sending, you compress the data. At receiving, you decompress the data. While you are sending, you encrypt the data. So while you are receiving, so you decrypt the data. So data will be compressed, encrypted, and encoded by presentation layer. Encoding means very simple. What are the data format it is? Like it can be a music file, video file, or text file, or HTML file, whatever it is. It converts into ASCII format. Okay, data is a bigger, automatically it will compress the data and encrypt the data, so then data is difficult to trace. Okay. Next layer is session layer. Guys, session layer only one line part. It create a session, maintain a session, and terminate the session. Session layer is will create session will be created and maintained and terminated. So what is the three things? So when you are sending a packet, when you are sending a packet means this is the source, for example, APC, BPC. I'm sending, so application layer, presentation layer, at session layer, session ID will be added, session is created here. And network layer, sorry, transport layer, network layer, data link layer, and physical layer. Data is transmitted, means you send a request, your data. So when you are sending, so a session is created and it is received at a BPC. So again, the physical layer to application layer packet is travels. application to physical, physical to application layer. Okay, and once it is received, and it will give reply, right? You send a request, for example, it will get a reply. So when you are sending that time, this session layer will take care of your session ID and it will transmit a data like this. Again, so once you receive the entire information, the session will be completed. You know, it is look like a very small and thing. It is very powerful session layer. I'll give you one example. When you done a payment, like you go to Amazon, Flipkart, or anything, you go to the payment option. You given a your payment things like your card information. You given. So once you are given, the process will start now for payment, right? Payment related, you got a OTP process starts. Then, if you check it, it shows do not press the back button or refresh the page. Do not press the back button or refresh the page. Why? If you put a back button or refresh the page, so the session will be changed. Again, it is new session ID. And as per old session ID means entire transaction should be completed in the same session only, not in another session. So you went to the Amazon, you open Amazon, session ID is created. Now you are added all the items in your cart. Now you are going to buy the cart items and then, okay, you given a payment, right? So you given the card details, everything. So whenever you click OK, then automatically connection is established to bank. Okay, from you to Amazon, Amazon to bank, the connection is established. Okay, then they will ask a OTP, you give an OTP, then click OK. Then once bank approved a payment, so bank will tell to your Amazon, yes, payment is done. So payment is approved, so your order is in the approved and it is start process, right? So whenever you enter your bank details and the request is sent to bank, within the session ID, the entire transaction should be completed. Okay, if you press the back button or refresh in middle, so your app in your place and your bank don't know what happened. Either transaction will be failure or it can be successful. Both you don't know. Okay, money will be cut and you don't know whether it is transaction successful, including Amazon also don't know if the transaction is done or not. Okay, so this is the power of session ID. Not only this thing, guys, when you download any data from internet, okay, so you send a request, you press the download button, it is getting downloading. Okay, any network disturbance occurs, any network or internet disturbance occurs, the session will be terminated. Okay. In generally, once you downloaded a complete data, then session will be terminated. But if any interruption is occurred, any disturbance is occurred in the internet or in the network, so your session will be terminated automatically. You cannot download remaining data. Okay. Of course, if you use IDM, FDM, those things, you can the session ID will be saved aside and you can continuously download. Okay, guys, this is a session ID. So application and protocols and their port numbers, presentation layer and session layer. Three layers are okay, guys.
Yes, sir.
Okay.
Yes, sir.
Guys, this is the transport layer. Transport layer, it is little bigger Then any other layers. Okay, what is transport layer? It provide a end-to-end connectivity. It segment the data. What is data segmenting? For example, I'm giving small example, just for example purpose only. Hello, how are you? Okay, so this is my data. My data is there. So then I put this is a big data. So what I'm doing, I'm going to segmenting it, and while I'm doing cutting this one, I'm also putting some number in it. Just for example, guys, it is not like that, but just for our understanding, the numbering and sequencing. So it segment the data and also they put a numbering and sequence on there. What is the advantage? For example, your source send a destination same message. First part is send, and it will give you acknowledgement. Like I received a first one. You send a first one is received. It means hello is received. Now I send a second one. So I get acknowledgement that second one is received, means how is done. Third packet I send, it is not received here. So I know acknowledgement. I send a fourth packet received, and there is an acknowledgement. Means U is received. Now the system is realizing, so our source is realize third packet is not received by destination. So what it will do? It will send this third packet again. Now it is received, then we will give you acknowledgement for a third packet. Then R is received. Now completely data is received at a destination. So destination understand they received a complete data. Okay, but it is not in order, so it will be ordered again as a thing. Okay, so it will be ordered. Okay, it is wrong order now, but it will be order again. So using numbering and sequencing. Okay, so it segment the data means cut the data into small pieces, number and put a numbering on it and put them in the sequencing order. Okay, so this is transport layer also do error correction. How it is? Same example, when you send a packet, so the destination not received. Okay, so it will do error correction means it will do resend the packet again. So next time it is receiving and arranging in sequence order. Okay. Okay. Multiplexing and demultiplexing of protocols also done by transport layer TCP and UDP. Okay, what is this TCP UDP, guys? We discuss about the protocols and their port numbers, right? We discuss protocols and their port number, right? These protocols are TCP type protocols are there and UDP type protocols also there. Protocols are TCP type protocols, UDP type protocols. You know, a lot of people when they just comes with this transport layer part, okay, they will read about TCP UDP, but just they read about TCP UDP, they really don't mind about what is this TCP or UDP part. Okay, just because it is a question and they will by heart a question and answer, but it is a exactly say, okay, exactly say it is protocols what we are using to communicate. Some protocols are TCP type protocol, some protocols are UDP type protocol, some are both. Like DNS is both TCP and UDP type. DHCP and TFTP are UDP type protocol. Simple to understand, guys. If you are using my communication with the HTTP protocol communication, it is a TCP type communication. If my communication is TFTP communication, it is UDP type communication happens. What is the type communication? When source send a packet to destination, destination will give acknowledgement to the source. Okay, if destination not send an acknowledgement to the source, source think destination is not received. So source received acknowledgement means destination is received a packet. Source not received acknowledgement for the packet, meaning is destination is either not received. Possibility it is not received. What source will do? It will resend the packet again. So that's why TCP type protocols called as a reliable protocols, connection oriented protocols. Guys, again, connection oriented, connectionless does not represent wired or wireless. Okay, connection oriented and connectionless means when you send a packet, okay, it is a two-way communication. It is simply say two-way type communication. You
So what is
send
the
a
means
packet and
reliable
you
and
listen.
non-reliable?
You tell me.
The reliable or non-reliable?
Yeah, that is, I will tell both connection oriented, connectionless, reliable and non-reliable kind of stuff. What it is, you send a packet and source knows destination is received or not. Source knows destination is received or not. It maintain a connectivity between source and destination, two-way connectivity. That's it is reliable and connection oriented. UDP type protocols like a TFTP, DHCP type protocols or UDP type protocols. What is their behavior is like that. They will send a packet to destination. That's it. Destination received a packet or not, source don't know. So source will keep on sending the packets, destination will receive. Or not received, source don't know. That is non-reliable. There is no guarantee packet is delivered or not. Just simple to understand. Acknowledgement is, yeah, check marks. What is this check marks? What is the blue check marks? Hmm? What is the blue check marks?
It is the
Deliver.
confirmation that other
Delivered.
person
Yeah,
see our message.
message is received.
Yes, sir.
Okay. Only this is message is sent, message is received, not at read by everyone. Or not at read. Okay. This meaning is packet is delivered. Same thing like this. TCP type protocols will verify that destination is received a data or not by acknowledgement. But UDP, no, it does not verify whether it is received or not, no one knows. That is connectionless and reliable, non-reliable protocols. Yes, some protocols are TCP type, some protocols are UDP type. It multiplexing means what are the TCP protocols we are using, what are the UDP protocols we are using in the communication. It multiplexes into TCP and UDP part. Windowing and flow control also doing. So meaning is it estimate the destination number of packets it can able to receive. Okay, it means I'm sending 5 packets. So it will tell I'm sending 5 packets. First receive all 5 packets and tell me. Okay. So in TCP, if you see this one packet send, one acknowledgement to another packet send, acknowledgement, another packet send, acknowledgement, another packet send, acknowledgement. Instead of that one, so what source will do? Source will send 10 packets at a time. So destination will receive all the packets. Once all 10 packets received, it will give the acknowledgement. Okay, that is the windowing and flow control differences. Guys, data in the any layer. So we have a 7 layers. Whatever the data in the layer, it can be application layer data, it can be presentation layer data or session layer data. The data we call it as a PDU, packet data unit. Okay, the PDU, packet data unit. So at transport layer, a TCP header is added to PDU. TCP header is added to your PDU, it becomes segment. What is this TCP header contains? It is information about protocols, port numbers. Okay, actually port numbers, TCP, UDP type wise port numbers, segment data, their numbering and sequencing, windowing information also in the TCP header. This segment will send to your network layer. Sir, now just now, sir, 5, 10 maximum. Okay. Okay, next one is network layer. Somebody you can get it. So next one is the network layer. Network layer actually dealing with the routed protocols means logical addressing, means logical addressing means IP addresses. Generally, we are using IP addresses, not any other addressing type. So generally, we are using IPv4 or IPv6 address. And routing protocols. Routing protocols will tell you how to reach the destination, right? So like RIP, IGRP, OSPF routing protocols. So network layer is dealing with your logical addresses like IP addresses and routing protocols. Routing protocols will tell you how to reach the destination. The logical addressing is give make a communication means to identify a device in the network type. Okay, so there is a network header is adding to your segment from transport layer. Okay, and at a network layer, the network header is adding. Network header means source IP and destination IP address is adding to your segment as a network header, and totally it is become packet. The originally packet means the packet is this packet only. Remaining are just general words we are using packet. This packet is sent to the data link layer. Hmm. Now last 2 points. Next one is data link layer. So data link layer is contain two sublayers. One is LLC, another one is MAC layer. Okay. Data link layer, two layers: logical link control, media access control. Okay. LLC, this logical link control dealing with the WAN protocols. You are communicating through WAN means you need a WAN protocols. Okay. So normally we are telling LAN and MAN, small network, very big network kind of stuff. Originally, WAN communication means if you use a WAN protocol, then it is a WAN communication, then only it is WAN communication it is. Okay, PPP, SDLC, frame relay, MPLS, these are all WAN protocols. Next one is media access control. So what is media access control? Already we did see, it is a physical address, it is on our NIC, network interface card. Okay, it is a 48-bit in size, 12 hexadecimal. Already we have seen MAC address, how to check MAC address also we have seen. And at data link layer, to the packet, data header, data tail is added. Data header is nothing but the source MAC address and destination MAC address. Data tail is CRC. What is CRC? Cyclic redundancy check. It is used to check the errors, means it will check the data, whether data is good or a corrupted. Data is good or a corrupted. Cyclic redundancy check. Okay. So what is data is being added? With a source MAC address, destination MAC address is added to packet plus CRC as a data tail. So total it is become frame. The frame is sent to the physical layer. Okay, what is the use of CRC for error checking? Guys, remember transport layer, error correction, data link layer, error checking. So it will make sure that is the data is safe or a corrupted. Last one is a physical layer. So physical layer converts this frame to the bit stream. Convert the frame to bit stream. This bit stream again converted into electrical signal or radio signal or a light wave based on what media, what connectivity it is, based on the connectivity. So first one is the Ethernet. If in case if you are using a Ethernet, fast Ethernet, gigabit Ethernet, then we use UTP or STP cables. Of course, the signal is electrical signal only. If you are using Wi-Fi kind of connectivity, radio signals. If you use a fiber optical type of connectivity, it is light waves. So these are the your OS layer, application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So compulsory read it, guys. So some maybe people are having a doubt, that is we are from different backgrounds. So how can we remember and all? So only thing is this is a intermediate type of classes only, nothing more. Okay. Somewhere we need one more space. Get one more. This bit stream part is not coming. Okay. So guys, when you are sending application, presentation, session, transport network, data link, and physical layer. Okay.
Sir, we require to remember all these things.
Yes. You have to keep reading, keep reading. No one will like you done a BTech or anything. First time you're learning, you don't remember. You have to keep reading, keep telling, and keep understanding. That's you can only one chance to remember. We can able to remember why, because I'm keep teaching and keep telling to people explanation, understanding. Like that I can able to remember. Same way, no other choice. Okay. So this is your from application layer, you are sending a request or a data. At the destination, it receives and at application layer. But how? Application is sending, presentation, encoding, encrypting, compress. And session layer add a session ID. Transport layer segment the data, and finally we got a segment. The segment sent to network layer, and network layer add a source IP and destination IP. We got a packet. The packet is added with the source MAC address, destination MAC address, and CRC. Then it is become a frame, and finally it will convert into a bit stream. For example, it is an electrical signal wired connection. So that is. So finally, destination receive the packet like this electrical signal to the physical layer, and physical layer convert this into the frame sent to the data link layer. At data link layer, it verifies source MAC address and destination MAC address, and verify data is good or corrupted with a CRC. Once everything is done, it extract the packet, send the packet to the destination. So 1 second. Okay, we need one dot here. Okay, so then it is so like that. So again, network layer verifies source IP and destination IP, and once it is okay, suitable, then segment will be go to transport layer. Transport layer will assemble all the segments into as a one single data and verify with the session ID. Presentation layer again decrypt the data, decompress the data, and decode the data. Okay, and go to the application layer. Application layer finally understand what source is sent, and it may want to require a reply, then it will give reply. While it is giving reply, again application, presentation, session, transport, network, and physical layer, sorry, data link layer and physical layer. Okay, so this is what I'm trying to put it. So that's it for today, guys. I think
Okay,
this is
sir.
somewhere
Thank you.
part of this. Okay, happy weekend, guys. So
Thank you,
tomorrow,
sir.
you.